Nanotechnology means working with objects that are 10 to the minus 9 meters in size. You continue to go smaller and smaller in size, say from a meter to a millimeter, which is 10 to the minus 3. A micrometer is a 10 to the minus 6, and then a nanometer is the 10 to the minus 9. That's pretty small. And so we're doing some tests in collaboration with the medical school that is involved in fighting cancer to look at whether we can enhance the efficacy of a drug simply by not changing anything about the drug itself, just changing about how you get it into a cell. One advantage that these materials have is they have a lot of internal volume. Meter square per gram is a way to monitor the surface area of a material. So if you pulled a piece of brick out of the wall, the surface area might be 10, 20, or 30 meters squared per gram. And that's about standard for a normal material every day. And the things that we make have surface areas of 1,000, 1,500 meters squared per gram. So they're many, many times more surface that you can use to do reactions. The advantage in my mind is just this idea of extra volume and extra porosity, extra surface area inside. You can actually take any drug that you already know will work for a particular application. If you can load a whole lot of it inside the particle takes care of the transport across the membrane. And now you have a whole lot of the drug that's actually inside the cell and then can leak out and do whatever it needs to do. If our materials have 100 or 1,000 times the surface area, that means potentially we can load 100 to 1,000 times the drug inside the particle. Everything gets smaller. There's a famous physicist, Richard Feynman, who said there's plenty of room at the bottom. And what he's talking about there is nanotechnology. So there's always a possibility for, as scientists, for us to work with smaller and smaller structures.